All right, so here we go. Radiometric dating. Test question review. Number 1, explain how radiometric dating works, and is there any evidence that radioactive decay rates can change? So radiometric dating works by radioactivity. When something is radioactive, that means that the molecules, the atoms, the stuff that makes it up changes over time. And it changes into something that is not radioactive. This process of changing is called decaying, and the rate at which it happens can be used to estimate how long it's been happening. And you can think of it like an hourglass. And we have particular names for these things too. So when something is radioactive, when something is unstable, we call that a parent element. And over time, that parent element decays into a non-radioactive daughter element. And so just like looking at an hourglass, the proportion that you see in each of these at any point can be used to kind of estimate how long the thing has been running. And that's the idea behind radiometric dating. And then, is there any evidence that radioactive decay rates can change? And the answer is yes. It has been observed that these decay rates can change based on solar activity. That in turn means that it changes based on the radiation we receive from the sun. The more sunspots there are on the sun, the more active the sun is, the more radiation it's going to send our way, and that can change these rates. Number 2, Mount St. Helens began erupting in 1980, and samples were radiometrically dated in 1996. Did these numbers turn out to be accurate? The answer to that is no. Talk about the 3 big assumptions that must be true for radiometric dating to be accurate. So those 3 assumptions are: you have to assume that at the very beginning you are only dealing with parent molecule or parent element. You're assuming there's no contamination by any non-radioactive daughter element at the start. You're assuming the decay rate has been constant the whole time. You're assuming no parent element has been added to or subtracted from the system. You're assuming no daughter element has been added to or subtracted from the system. And if you remember from our note-taking session, that ends up coming to 7 total assumptions that you have to believe are true. Which, if any of these assumptions, can we scientifically verify? And the answer to that question is not really any of them. You need to be there at the start and along the entire process of decay to verify 6 out of the 7 assumptions. In terms of the decay rate, all you know about that is how fast it's decaying in our labs when we actively observe it right now. There's no way to know if it's always been that way. Number 3, how can carbon dating be used to demonstrate that the Earth is not millions or billions of years old? So for this one, carbon decays very quickly compared with most of the elements we dealt with at the beginning of class. Some of those elements like potassium decaying into argon, that sort of thing, those half-lives are billions of years. They decay extremely slowly. So carbon decays a lot faster than that, just 5,000 some years for it to go through one half-life. So the thing with this is after 15 half-lives, there should be no detectable carbon left that our machines should be able to pick up. As expensive as they are, they're only so sensitive. So after 15 half-lives, that would correspond to about 90,000 years, our machines should not be able to detect any more radioactive carbon, any more carbon-14. And yet, when we look at things like coal, that is hundreds of millions of years old, supposedly, diamonds that are supposedly billions of years old, dinosaur fossils that are tens of millions of years old, we find detectable radioactive carbon. But it shouldn't be there if it's been existing that way for billions or millions of years. All that carbon should have long since decayed to the point where our machines just can't see it anymore. And yet there it is, looking at us smack in the face, telling us that these things really aren't that old. Number 4, why does carbon dating routinely give us ages greater than 6,000 years? So in order to understand this, you have to understand first that there's lots and lots of coal in the world. So coal is the number 1 energy source that the world uses, and coal got there by originally being vegetation. That vegetation got buried over a period of time, and then it got pressurized and it turned into coal. Now, we believe that that coal got there as a result of Noah's flood, just like the fossil record. It was washed into place. So all of that coal at one point before the flood was all growing on the surface of Earth. Well, guess what? If you took all that coal and the vegetation that produced it and planted it on Earth right now, it would die very quickly. It would die very quickly because there's not enough carbon-12 in the atmosphere right now to support it. It's like putting too many people in a small room with too little oxygen. You can only last for so long. So what this means is that if all that vegetation was planted in the world before the flood, there must have been a lot more carbon-12 in the atmosphere. And if there was more carbon-12 in the atmosphere, for the reasons that we talked about in our notes, then that's going to throw off your carbon decay rates a little bit there. It's going to throw off the results that the machine spits out. Because the results your machine spits out is based on the ratio of carbon-14 to carbon-12. So again, we talked about this in the past. Carbon-14 decays over time. It disappears. It turns into nitrogen-14. So in something that has died recently, it has lots and lots of carbon-14 compared with carbon-12. But as time goes on, that ratio changes because the carbon-14 is, again, disappearing. And the carbon-12 remains consistent because carbon-12 is not radioactive. It is stable. It doesn't go anywhere after you die. So if the atmosphere pre-flood and after the flood, at least for several hundred years after the flood, had extra C12 in it, then when we date these things, they're going to come back as being artificially older for that reason. If you have extra C12 in the atmosphere, it's always going to spit back dates that are older than reality, and that's why we're getting results of 50,000 years for diamonds and the same sort of thing for coal seams and dinosaur fossils, because the atmosphere at the beginning of the flood was much different than it is right now. It needed to have that extra carbon-12 for those plants to actually live. Number 5, explain how the presence of helium in zircon crystals can be used to demonstrate that the Earth is not millions or billions of years old. Well, in the same way that helium leaks out of balloons, it leaks out of zircon crystals. It's a very, very small molecule, so it can leak out of the rubbery balloon material just like it leaks out of extremely hard zircon material. And over time, just like with the balloon, that helium goes away and the balloon ends up on the floor. It should be leaking out of those zircon crystals too. Now, these zircon crystals are supposedly billions of years old. But if they're really billions of years old, that helium shouldn't still be there. So that points exactly in the opposite direction. It points to these zircon crystals and everything else we've talked about in this chapter as being much younger. Not billions of years old, but rather thousands of years old, exactly in line with what Scripture teaches.